Okay, so I'm going to show you how some really helpful shortcuts for standard form. Now, the first thing that you must never forget is that there's no shortcuts for add and subtract. There's only shortcuts for multiplying and dividing. And these are based on the indices laws, or the index laws, that we learned earlier. And you can find in the video playlist under indices and powers. So first I'm going to do an add and subtract example and show you what you need to do if you see that. So for instance, if you had 3.5 times 10 to the 4 minus 9.2 times 10 to the minus 2. The first thing you need to do is write them as whole numbers or decimals. Take them out of standard form. So for instance here I've got 3.5 times 10, times 10,000. So I'm going to end up with 3.5 and my 3 is going to move 4 places forwards, using my marbles. So my 3 is going to go 1, 2, 3, 4 places and it's going to sit here. So I have 3, the 5 is going to follow, and then I have to fill in the 1, 2, 3 gaps behind it. Notice that the 5 here, because it's not on the whole side, it's on 10th side, cancels one of these 10s to move it over into the whole side into a unit, and then I've got 3 zeros left to add on the end. So I know now that I've got part of it calculated. Now I've got 9.2 times 1 over 100, because 10 squared is 100 over 1, and the reciprocal of it, because we've got a negative, means that we flip it, so we get 1 over 100. So that means we get 9.2 divided by 100, because you times your top numbers together, and 9.2 is really 9.2 over 1, and we times our bottom numbers together. So 9.2 divided by 100 means that our numbers are going to move backwards by 2 places. So our 2 is now going to sit 1, 2, it's going to sit here. Our 9 is going to move back 2 places, it's going to sit here. So now we need to fill in all the gaps. So this would become a gap and this would become a gap with zeros. So now our actual sum that we're going to work out is 35,000 minus 0.092. Now, because we've got a decimal, the first thing I would do is put a decimal place in our whole number, because that will help us line everything up. So I've got 35000 point, and then I've got 0.092. Now notice that I've got blanks here, and that's not very helpful if we're taking away. So what I'm going to do is put zeros in their place. So this is particularly hard. What I need to do is borrow from this 5 and carry my 10s all the way down. So 0 minus 2 I can't do. I can't borrow from this one, I can't borrow from this one, I can't borrow from this one because there's nothing, I can't borrow from this one because again there's nothing, or here. So I'm going to have to borrow from my 5 all the way up here. So if I borrow from here, I'm going to end up with 10 here. I'm going to have to then borrow a 10 from that, which will give me 9 of those, and 10 here. Borrow from that, which gives me 9. Carry my 10, borrow from that. You get the picture. We just go on and on and on and on until we manage to make 10 at the bottom. So now I can do 10 minus 2, which equals 8. Then I've got 9 minus 9, which equals 0. 9 minus 0, which equals 0. Don't forget to put your point in. Always draw them really big, because in your exam they will scan your papers, and if you haven't drawn it big enough, the computer, or dark enough, the computer won't pick it up and the examiner won't be able to see the number you really mean. 9 minus 0 is 9. 9, well really there's a 0 here. Minus 0 is 9, and again there's nothing here, which is a 0. which is 9. 4 minus 0 is 4, and 3 minus 0 is 3. So that is your answer. So if you get an add or subtract, there's no shortcuts. Just work out what both the numbers are in real life rather than in standard form, and then take them away from each other. But just make sure you're really, really clear about where your decimal point sits, and if you have gaps, fill them in with zeros. Now, when you multiply or divide standard form, you can use the shortcuts based on index rules. So for instance, this is one of the index rules we learned before. 10 to the power of 2 times 10 to the power of 5 equals 10 to the power of 7, because you add these two together. So you have 2 plus 5, which equals 7, because this would mean 10 times 10 times 10. So this would be this one, and this would be 10 times 10 times 10 times 10 times 10 times 10 times 1, 2, 3, 4, 5, 6, 7, 10. Notice in total, I've got this 7 plus this, sorry, I've done it wrong. Sorry guys, read the wrong bit. So I've got my 5 here, 1, 2, 3, 4, 5 lots of 10 times itself, and 2 lots of 10 times itself here. So we end up with 7 in total, because we've got 1, 2 plus the 3, 4, 5, 6, 7. Now, if you can remember, if you have 10 to the 5 divided by 10 to the 2, that means that you have 10 times 10, which 5 times, which is 10 times 10 times 10 times 10 over 10 times 2 times itself twice. And these will cancel. So these two cancel, these two cancel. So we end up with 1, 2, 3, 1,000 over 1, which equals 1,000. And that tells us that it's 10 to the power of 3. So when you multiply, you add the powers, but when you divide, you take them away, because 5 take away 2 equals 10 to the power of 3, which is what we've just calculated. So what I'm going to do now is use that quick shortcut rule for multiplying and dividing to help you with this. Now, if you see two numbers in standard form being multiplied together, because they're both in the same base, i.e. they're both to the power of 10, you can shortcut rule them using your indices rules. What you need to do is treat your numbers as one base and then your powers as another. So the numbers you treat normally, essentially here what we have is 9.2 times 6.3. And then once you've worked that out, multiply that by 10 to the power of 3 times 10 to the power of 2. Now you do this normally, and this is a shortcut. So I'm going to have to work out, using my normal method, 9.2 times 6.3. So what I'm going to do is 92 times 63, and because I've multiplied this by 10 to get to here and this by 10 to get to here, I'm going to have to divide my answer by 100 to make up for my two manipulations. So I've got 92 times 63, that's a 0 there, that's a 0 there. Let's draw some lines in to help myself, some grids. So 3 times 2 is 6, 3 times 9 is 27, but because it's 90 times 3, it's actually 270. Then I've got 6 times 2, which is 18. No, it's not, it's 12. What am I doing? But 60 times 2 is 120. And then I've got 90 times 60, so it's 9 times 6 with 2 zeros. 9 times 6 is 54. And then I'm going to add them all up, so I've got 6, 9, 4, 5, 6, 7. But remember that I've got 5, 7, 9, 6, and I've got to divide it by 100. Now notice whenever I do any calculations where I've done a manipulation, I always make a note of it so I don't forget. It's so easy to do this huge sum and then forget, so always put it in square brackets to remind yourself that it's something you have to sort. So if I'm dividing this number by 100, my decimal point is going to be here. Now I can shortcut rule these two. So I'm timesing them, so I'm just going to add my two powers together, so I get times 10 to the 5. Now this looks like you've finished, but in fact you haven't, because we need our number at the start of our standard form to be between 1 and 9.9 recurring. So actually what we need is 5.796. So what we've actually done here is we've divided by 10. So that means we need to times by 10 this side to cancel it out. So 10 to the power of 5 times 10 to the power of 1 is 10 to the power of 6. And that's our answer. Done. So here's an example of a particularly hard one that would catch most people out. What you need to do is first divide this number by this number. So we're going to do 6.9 divided by 23. So I'm going to create a bus stop and put 23 on the outside and 6.9 on the inside. Now make sure you put your decimal point in on both top and bottom so you don't forget it. So will 23 go into 6? No, it won't. So my 6 hasn't been dealt with, so I need to carry it forwards. How many 23s go into 69? Well, that's 3. So I've got 0.3 so far. Now I have to do 10 minus 2 divided by 10 to the minus 9. Now here is where good notation and showing your workings makes a massive difference. People tend to go, oh, minus 2 minus 9 is minus 11, but the answer is actually 10 to the positive 7, and I'm going to show you why now. People forget that they always have to write a symbol for their sign. Now when we divide powers, it takes them away from each other. So actually what we have written here is minus 2 minus minus 9. Now remember, if two signs are touching, they're multiplying, they're interacting, so they have an effect on each other. So we actually have minus 2 plus 9. So we're going down 2 and up 9. So 2 is cancelled off of 9, which gives us 7. So now we have 0.3 times by 10 to the 7. Most people would stop here, but actually that's not correct, because 0.3 is less than 1 to 9.9 recurring, and that's the number that that's the range that our number has to fit in between. So what we're going to have to do is make this a whole 3 by timesing by 10. So if we've times by 10 this side, we need to remove a 10 from this side to make up for it. So we end up with times 10 to the 6. And if you can get your head around that, there's lots and lots of marks in an exam available about, on it usually.